So, okay, thank you. Yes, let's make a start now. This ideally today would have been just a chance for you to work on your team projects, but because this week was a shorter week, we do have a little bit more theory to do to start with. So I'll go through that, and then once we've done that, then we can get into the breakout rooms and work on the team projects. We don't have a homework today because the practical examples we have are quite detailed. So I think there's plenty of for you to work on there. But I'll come on to those, the practical examples at the end of the theory. So let me share my screen. And hopefully you've got this from Discord as well. I think I shared it there. Okay, I'll turn my camera off just in case. Okay, so I want to talk a little bit in more detail about program-derived accounts because this is an area that you definitely need to know about. We want to obviously have state in our blockchain. We need to know how to modify that state, and we need to know what the rules are around that. And part of that is deriving accounts for the programs to hold a state, so that the program can modify state. So the design constraints we have when we're interacting with the program is that the programs themselves are seen as stateless, so that any state that we want them to interact with has to be fed to them. And then the second constraint we have is that the program can only alter state of the accounts that it owns. So we need a way to link these together and make sure that we can own an account and have a mechanism around that. The difference can be that, as we'll see with the way that these accounts are set up for programs, this is different to a normal account that has a private key and that can sign for things. With a program-derived account, they are set up differently, so they don't have a private key, but they still need to be able to sign for things as well. And the way that they are derived is from a collection of seeds, so some data that we can decide. Also, we need to the program derived account is specific to a program, so we also need the detail of the program itself, so the program ID, and then from that we can try and derive an address for this account. But we don't want this address to be able to be, we don't want someone to be able to find a private key for this. So there is a neat mechanism that we can use to make sure that there is no private key for this account. And this is from the fact that we're creating our private keys from points that lie on elliptic curves. So if we have a point on an elliptic curve, that can represent a public key and a private key. So what we can do is to get a point that is not, that we know is not on the curve, so we know that it won't have a private key. And you can sort of visualize this perhaps by thinking that we may start with sort of discovering some point that's determined by the seeds that we provide and the program ID. And then this may actually end up being on the curve. So what we can do is to give it a bump and move it off the curve. So we provide this extra parameter, the bump, to move it off the curve. And this may take some attempts. It's not, I think you say that it's sort of 50-50 chance that you might get something that is actually on the curve. So it may not work first time. So the pseudocode for that, just to show you what information we provide. So yeah, specific to a program, so we need to provide the program ID. some seed for that to make it unique, and some seed bump as well. And one of the features of Solana is the way that it gets its great scalability is that it has this ability to run things in parallel, and to do that it needs to be able to handle concurrency, and so it needs to know the accounts that are going to be used by a program, and what state in those accounts may be modified, so that it can work out if there are going to be conflicts, and it can handle those. So what this means is that in the process of when we create or when we submit something to C level, to the runtime, we need to we need to have worked out this this address to begin with, and then also because the way accounts work is that they have this rent idea, so we also need to be able to give it some lamp ports to make sure that it will have enough rent, and it also needs to be marked as writable. So this creation process, this way we have of deriving the PDA, means that we start off on the client by working out the address that we're going to create, and then we can then pass to the runtime. But rather than having having this sort of create the address sort of provided for us, we need to be able to specify this up front, so we can do all these sort of add the lamp ports, etc., because we need to know which accounts we're talking about. So what this looks like, there's a number of steps I show here. So you start off on the client, so off chain, and we have some JavaScript here that will return us the PDA and this bump factor to ensure that it is not on the curve, and to provide to work that out, we provide some seed or seeds, and then the program ID, because it is specific to a program, and then that program will be the owner of this account, and because it's the owner, then it will be able to modify the state of this account. Once we've done that and we know which account we are trying to create, then we can start to put together the instructions to do that. And this is what that looks like. So we're creating this transaction instructions, and we need to pass in some keys. So we'll need to provide the key of whoever's going to be paying for this transaction, and then the account that we want to create itself. That's the account to init, and it's got these details, and then also we need to pass in the system program address as well, because that is going to be used to do the creation, and yeah, we need to say again, we need to know the program ID, and then some details about, so that it can do the work out the amount of lamp ports that are needed for the rent. So we have some data being passed in there as well. And once we've done that, we can then send that off to the chain as a transaction. And then this, when this comes onto chain, it will be handled in this way. So it will be able to work out the size of the amount of rent that needs to be paid for this account size, and the details of the account address that it is going to create, who sent this, and the program ID. And then that then calls the system program to do the creation, as you can see here. So it's passing in clones of the accounts that are involved here. then the data that's needed to specify it. So what effectively has happened is on the client side, we've worked out these details. So we've provided the seeds and the bump, and we've derived or found the PDA address from that. And then this process is repeated really on the chain as well. So that should then create your PDA. So that should do the setup for you. The other way to do it is you can do it just from the client effectively. So you can there are commands to do it just from the client, and those details are given there. So that yeah, you can do it just from that. As we shall see later, you need to make sure, because you have this idea of this being created on chain and on the client, you need to make sure that what you're doing matches, that these two things are in sync, so that you don't get any kind of mismatch. Now, one of the things you'll need to think about when you're doing this is how to select a seed. So I didn't say anything about that. I just said we would have some sort of seed in there, but I didn't say what sort of process we would use to derive a seed, or how that would be managed. So this is, I want to talk about that a little bit now, because you need to think about this in a structured way. We have to have a structured way to do this. And if, to explain this, I'd like to take an example. If we had a program, we're calling here the restaurant program, that is going to need an account, so the restaurant PDA, which it will own, and then that will be used for state. So that's what we're aiming for. But then if we want to create more, what process should we'll be thinking of to know how to create more PDAs? And essentially, because we have the same program ID, what we're saying is we're going to be doing this with different seeds to keep these PDAs different. So how do we manage that? And some potential ways to do that is that you could use a counter for that. So you could create your first PDA with the program ID and a counter, and then once you've done that and you've got that one set up, then the next time you want to do it, you could just increase this counter by 1 and repeat the process, and this will create a different address for you, a different PDA for you. So as I say there, the first time you do it, you might use 0 for the seed. The second time you use 1, and you just increase this counter. So this is a nice deterministic way, a nice structured way of managing the seed and of managing the working out the PDA, so that you don't get them repeated. The problem with this, though, is that we need somewhere to store this counter, this latest value of the counter. Obviously, we want to know what the last one was so that we can increase it. So we need to store that somewhere. So that's, well, there will be different options for that. I mean, maybe it would depend on what your application is, but potentially you could do that off chain, or perhaps you would want to keep that on chain. And if that's on chain, then you're kind of, you need an account for that. So that's a drawback to this approach. But the advantage to this approach of doing it in this very structured way is that you can very easily iterate through these counters to work out all of the PDAs that you have created. If you're searching for one, it would be a relatively simple process to search through these. So that's one way we could do that. It's one use case for this is that you may find that, well, the accounts themselves are they have a maximum size, and so this could be problematic. You may, because you want to you might run out of space in one account. You want more. You need, excuse me, more than one account. So you could quite easily make a nice list in this way by just doing this just repeating this process and creating one account after another, and they're all indexed effectively by this counter. And then the only limit you would hit then is if you try to get above the value of the count, you hit the maximum size of the counter, but that is going to be quite large, so you're probably not going to hit that. And then another approach you could try is, or that might make sense in your application, is to use a public key as your seed. So if you have this idea that someone will be creating a new account, and then different people will be creating them, and then these PDAs will be not just specific to the program ID, but will have some relation to the person creating them. Then maybe it would make sense to use the key, the public key of the person's doing this process as the seed for this. And it was a similar process then. You just would use a different public key each time. The drawback to that, though, is that then there's no way to work out an easy way to work out how to iterate through these. Maybe if you had a whitelist of these accounts, or if there was something like that you knew, it might make more sense. But otherwise, it could be a drawback, the fact that you wouldn't necessarily know which public keys had been used in this process. But whichever way you decide to do this, it really should depend upon the type of application that you have and what makes sense to the program design and what your application is trying to do. Okay, and then a step sort of further from that is that you can also chain accounts together by using sort of splitting the seed into components, where an address of an existing PDA is used as a component in the seed to create the next PDA, and this will kind of make a chain of the PDAs that you are creating. Obviously, then you would need some way to differentiate between the ones that you're creating. So perhaps via a counter or whatever it is. You'd need some seed derivation pattern. But because you have this, you're basing the derivation partly on the previous PDA, then that gives you a means to sort of to traverse the chain in quite a nice manner. And there's some examples there. And just to be aware that once you do, if you have something like this, some chain like this, where you're creating them dependent upon the ones that have previously been created, of course they are all still owned by the restaurant program. That's the owning. That's the owner of all of these accounts. That's because that's the program ID that you are passing in to all of them. So they're all owned by that, and that means that program can then update the state of all of those PDAs. Okay. And then, I mentioned earlier, you have to be careful if you have some scheme, you need to be careful that this is the same on the client and the chain side. If it's not, then you could potentially get this type of error if you've miscalculated the PDA address, and it's you could get this that type of error. So if you see that may be what has happened. And the system program is using this then to work out, to check that, to make sure that it is being being created correctly. Yeah. Okay, so that's just a little bit more about PDAs, and to give you an idea or some things to think about when you're designing an application and you're trying to think how you're going to create the, or how you're going to have the state in your application, and how you're going to create these accounts to hold that state. These are the types of things you will need to think of. And then we have some practical examples for you. So again, there's details there if you can find them in the repo. And the example number 6 is an example to create the PDA. That's quite a straightforward one, but there's still a fair amount of detail in there. So please do go through that and make sure that you understand what that is doing. Don't just sort of run the things to deploy it and call it, but also make sure you go through and understand all of the pieces of that. And then the example number 7 is a little different, and it's it relies upon something I spoke briefly about yesterday when we were talking about access control, and the kind of the difference between that and the being able to modify state. And so what example 7 is about, so this is example 7 here. And what this effectively is doing is it's allowing people to interact with this program, but there are some people who are valid, and some accounts that are valid, some accounts are invalid. And what we're doing is just using access control to work out which accounts are valid and which are invalid. And then we're updating a counter to reflect that and reflect which to count up the two different types of counts for that. So again, it shows you about access control. So please have a look at that and sort of make sure you understand the difference between that type of access control and the idea of ownership and being able to modify data, because this is modifying data, but we are modifying state, which is owned by the program, not dependent upon, the program is allowed to modify the state each time because it's updating these counters, but that which counter we update depends upon the access control that we've put in the program. Okay. So those are the examples. So I suggest you spend some time looking through those and making sure you do understand the way that those work, and you get those concepts clear in your mind. All right, and as I say, there's no specific homework other than going through the rest of the examples. So we can now move on to the team project. Before we start that, though, just a couple of points. One is that what we've been talking about this week is really the sort of the most fundamental way of writing programs in Solana, and this is something that you really should know, because certainly as you do more and more complex contracts, this is something you will need to understand. But there are some shortcuts that you can take, and there is a framework called Anchor that we will look at next week that really helps smooth this process, smooth the development process, and gets rid of some of or takes care of some of the boilerplate. So what I would suggest when you're looking at your team projects is don't start writing all of the code now, because next week when we come onto Anchor, that will be it will be better for you to use Anchor to write the code. It will be a simpler way for you to write the code. You can still write code snippets, and what I suggest you do is to spend the time today and certainly till next week, to think about particularly the program design and to decide on what project you want to work on, how that is going to work, and then think about more about the design of the project and things like how the accounts are going to work, how you're going to store state, what sort of state you will need, what are the interactions between what's being handled on chain, what's being handled off chain. Those types of things you can think about before you actually need to start coding. So yeah, Anchor, yeah, it's called Anchor. Yeah, so that's everything I think we need. So you've got plenty of time, so we can then carry on with the team projects now. I think maybe, yeah, it might be nice if perhaps that if we work on them until maybe 1:15, and then if we come back to the main room and we can go through the teams, and everybody and someone from each team could just give a short, just give a description of what idea you're going to be working on. Yeah, just give us an update of how things are going. So yeah, if we could I'll stop sharing, and then we can
yeah, I'm gonna
create
open
some
up
breakout rooms, please.
the 13 rooms are being opened up right now. Please join the other room with your corresponding group.
Mm-hmm. And as always, if you have questions, please pop them on Slido, but we will also come into the rooms themselves to check how people are doing. So okay, I think we're all back. So we'll just go through quickly what the teams are working on. So all we need from this is just an idea of which of the projects you've decided to work on, or any unique features you've decided to add. Obviously, I know some teams are away. Some we may need to reorganize some of the teams a little bit as well. But yeah, just to get an idea that how you're getting on. So we'll start off. I don't think we've got team 1, so we'll start off. I'm not sure even if we have team 2 either. No, I don't think we do. So shall we go to team 3?
Team 3.
I'll try. Sure. The rest of my team can jump in if I'm flailing, but basically, all right, so we haven't fully nailed this down, but our general idea is that we want to create a voting application that would require as some kind of a collateral in order to be able to vote an NFT. So we have 5 people in our group, so we would generate 5 NFTs, and each person would receive one of those NFTs and then would submit the NFT and get validated and then be able to place the vote. And at the end, after 5 people have voted, the voting would close and the results would be displayed.
Cool. Sounds good. Nice one. Thank you, team 3. Okay, team 4. Do we have a team 4?
Yeah, we can quickly talk about it. Again, fleshing out the idea still, but basically thinking of combining a DAO voting with kind of an NFT curation. So basically, people can suggest or propose NFTs, put them up for voting, and then basically the DAO will look to either acquire them or fractionalize them, and yeah, looking to kind of combine those 2 ideas. But that's how far we have gotten, to be honest.
Great. Yeah, that sounds good. Sounds interesting. Thank you, team 4. And team 5. Do we have a team 5? Silence.
Hello.
Okay. Oh, here we go. We do.
We're working on a lottery program It's our plan. Today we were just with 2 people, so we don't really have time to get into all the details too much. But we were thinking to make a lottery, and then with Solana you could buy an NFT, and through an oracle, so probably Chainlink, we would generate a random number and give this as a property to the NFT. And based on this, we would pick a winner. And maybe we were still looking into this, how we could see the time, but we were thinking about using block stamp timings for this. And then based on the block, we would set the timing, so the deadline.
Sounds good. Yeah, another interesting one. Thank you, Team 5. Okay, and Team 6. Do we have a Team 6?
Yeah, we are also planning a voting system with fungible tokens. And we are planning to do a whitelist. So in order to get the registration for you receive and you could vote yes or no, there is a whitelist with a deadline. And we're planning to get the number of yes or no votes. So in order to plot it and show the statistics of that. And yes, that's it.
Great, sounds good. Excellent. Thank you, Team 6. That was Team 7. Do we have a Team 7?
Hello, everyone.
Hello. Hello.
We've been thinking about building the game, tic-tac-toe game, and
Nice.
for this moment, we're thinking to make it quite simple, just a front-end application which would send on-chain requests after each move, and the on-chain program will be validating those requests if the move is valid. For example, if it's made on a valid field, or if the game's still going on. So, for example, if there is a winner already, and that's it. I think just a simple tic-tac-toe game with simple validation.
Simple is good. Yeah, simple is good. Great. So yeah, I think you're the first one so far to look at that. Excellent. Thank you. Thank you, Team 7. Okay, Team 8.
Hi.
We have a team.
We have decided to work on the tic-tac-toe too. We have a plan to add 2 additional features to it. The first one where people can put their money before starting the game, so somehow they are betting against each other for the final result. And the other one is that we are going to specify a time limit for each player in order to some kind of limit the overall time of the game. And we are going to implement a simple front end where users can fill out a dot. And yeah, that's it. And we are working on the logic in order to finalize it together on the Monday session.
Nice. Great. Another tic-tac-toe. Cool. Thank you, Team 8. And Team 9. Another tic-tac-toe or something different?
No, for Team 9, we want to work on Russian roulette. So we were thinking about using randomness for the fatal bullet number. And also each user will have to stake some amount, and if he wins, he can double his money. And then we'll add the future with the leader board score. Yeah.
Nice.
That's it.
Cool. Great. Okay, I'm glad someone's working on that one. Thank you. And Team 10.
There we go.
Yes.
Yeah. We decided to build a lottery. We are discussing the logic of the game right now. That's it. Yeah.
Great. Thank you, Team 10. Okay, and 11.
I guess I can present for us. Our idea is pretty rough. We're planning on doing a voting system. We wanted to do Russian roulette, but we'd have to learn random number generation. So we might switch in the future, but for now we're going to try a voting system, and we think that we might try and turn it into some type of prediction market. We think that might be interesting to, have a prediction market on Solana. But I mean, for now, we're just making a very basic, simple Solana voting system.
Great. Very interesting. Yeah, excellent. Thank you, Team 11 and Team 12.
Hi, I'm Ayush from Team 12. We are trying to we'll be building a poll app, like a simple, like where users can go and just create poll and just add their options. And we'll be just creating that. Yeah.
Sounds good. Thank you. And finally, Team 13. If we have a Team 13.
Yep. So we are thinking of making a fungible charity token and then create a voting application around that to firstly, we'll do just a basic yes, no type vote. And obviously we'll see if the person trying to vote is whitelisted, and we will potentially try to see an experiment with different types of words if you have time to see if you can create, words that are executable in terms of like tokenomics. But yeah, that's just for, we'll see how we go.
I think that's a good approach to have some stages. Yeah. Nice. Thank you, Team 13. Okay, I think that's everyone. And I know there are some teams with fewer members, so there maybe we'll combine some of the teams next week, but we can leave that till then. So yeah, we're pretty much out of time. So thank you, everyone.
Can I mention something, Lawrence? Sure. Excuse me. I think it would be amazing, as I talk to my team members, that you specify a little amount of time so we can keep up with the class flow and some kind of dig deeper into the topics.
Sorry, I don't really.
I think
like a timetable.
Our place, a little is hard to achieve. We have the same problem through our group, and we all are lagging behind from the class pace.
Okay. So would you like more time to come finish off the homeworks, etc.?
Yes. Reviewing the lessons or working on the homeworks together, or some kind of hesitating on those topics in order to perceiving them more in depth.
Okay. Yeah, certainly we can do that. Yeah, definitely. All right. We'll sort out something for next week then for that. Maybe have a lesson just to go through those.
Right. Thanks a lot.
Perfect. No problem. All right. Then, yeah, I think we're done. Thank you, everybody. Hope you have a good Friday and a good weekend, and we'll pick it up again on Monday. Thanks, everyone.
Thank you.
Thank you.
Thanks.